Hello, here we have another force problem. This one has a person with a mass of 68 kilograms who is hanging by a rope from a helicopter as it moves at a constant speed. Because of a force due to air resistance, which acts in the direction opposite the person's motion, he hangs at an angle of 22 degrees from vertical rather than straight down. Calculate the force due to air resistance and the tension in the rope. Okay, so in other words, the helicopter is up here somewhere. All right, it's moving from left to right, and because of that, the air resistance is pushing him back the other way, and so there's an angle here instead of just hanging straight down. So we start this the same way we start all of our force problems. We draw a force diagram. So here's a dot, which represents our object, which is the person. And then for the forces, we have the tension in the rope, which is up this way somewhere at an angle of 22 degrees from vertical. We have a gravitational force, which is straight down. And then we have the air resistance force. And because the person is moving to the right, that means the air resistance force is going to be moving to the left. And I'll call that R for resistance. So now that we've got our force diagram drawn, our next step is to apply Newton's laws of motion. So we're going to say, or Newton's second law to be precise. So we're going to say the sum of the x components of the forces equals the mass times a sub x. Let's see, I've got two forces with horizontal components to them. So this is going to be Tx minus Rx is equal to 0. Okay, our acceleration is 0 here because it says the helicopter is moving with a constant speed. All right, Tx, that's going to be the x component of t. This is going to be t times the sine of 22 degrees. Okay, it's the sine because we want the horizontal component here, and as you see, if this is our 22 degree angle here, then the side of our right triangle that we're looking for, the horizontal side here, is in fact the side opposite the 22 degree angle. Okay, basically the x component is sine rather than cosine because we're measuring the angle from vertical rather than horizontal as we usually do. Let's see. So Tx plus Rx, the x component of R, because it's to the left, is going to be minus R, and that all equals 0. Okay? And I can go one step further. I can say t times the sine of 22 degrees is equal to r, but I'm stuck at this point because I don't know what t is and I don't know what r is. So let's circle this and move on, and we'll look at the y components. So the sum of the y components of the forces equals the mass times a sub y. That's going to be, let's see, the forces with vertical components are going to be T and W. So I got Ty plus Wy is equal to 0. Again, my acceleration is 0. The y component of T is going to be T times the cosine of 22 degrees. W is straight down, so its y component is just going to be minus W is equal to 0. That means T times the cosine of 22 degrees is equal to W, which is mg, which is 68 kilograms times 9.8 meters per second squared. So T cosine of 22 degrees is equal to, where is that? 666 newtons. And that means that T is equal to 666 newtons divided by the cosine of 22 degrees, which works out to 719 newtons. Okay? Notice that's one of the things that we wanted to calculate here. So that's part of our answer. All right. The other thing we want to know is the air resistance, and we can get that by going back up to here. So now that we know what T is, we can say this is 719 newtons times the sine of 22 degrees is equal to R. And when we multiply that out, that gives us R equals 269 newtons. And that's the rest of our answer, which means we're done.